Okay, we also have a rule for the quotient of two functions. F over g prime equals, it's a little more complicated. You're going to have an f prime g and a f g prime or g prime f. I prefer to write it this way with the quotient rule. And just because there's a difference in the sign, so it's f prime g minus g prime f divided by the square of g. Now we'll look perhaps into the reasons for this. In a full engineering calculus course, we would go pretty deeply into why this is. But for right now, in the applied calculus course, let's just learn to use it. So let's apply this formula to this function. Now I've observed that people in class didn't seem to have any trouble doing this. There are a few little errors in detail, but following the scheme with the formula in front of everybody, everybody seemed to do pretty well with this. So we identify f as our numerator function, obviously, and g as our denominator function, because that's the way it is in the formula. So f prime g is going to be, well, the x plus 3x function is the f, so we do that, take its derivative, divided by, or multiplied by the denominator function, square root of x minus x squared, minus the derivative of the denominator function, again, square root of x minus x squared, derivative, times the numerator function, x squared plus 3x. Now this becomes quite easy with practice, and it doesn't take all that much practice for this to kind of get into your bloodstream. And then we divide all that by the square of the denominator function. Okay, now it's just a matter of going through and doing the operations and simplifying things. And I didn't get the entire simplification, but I got us down to a relatively simplified form here. And I'll probably talk a little bit more about that when I get down there. This is as far as we get in class. We were running out of time. Okay, well, x squared plus 3x prime. X squared prime is 2x. 3x prime is 3. And that's multiplied by the quantity here, and you see that. And then the square root of x, as we saw previously, derivative is 1 over 2 square root of x. And the derivative of x squared is 2x. We have a minus there, so we have a minus 2x multiplied by this function. And then we square the denominator. And that's easily squared. You just have to be careful. And I believe we get x to the fourth for the square of x squared. And we get x for the square of the square root of x. And then our other term is going to be double the product of these two, negative 2x times the square root of x. And it looks like I messed up there because that should be negative 2x squared, shouldn't it? Well, that just appears in the denominator, and that's going to have a couple of effects. It'll make that 3 halves into 5 halves. That's really the only effect it'll have. Of course, we want to write the square here as well. And we'll see that in a minute, but let me go ahead and pause for a second and correct that. Okay, the only change has been I put a 5 halves here and a 5 halves here, and we'll see how that happens. We understand that that has to be an x squared because when we square this, that is what we get. Okay, well, then we distribute 2x times the square root of x is 2x square root of x. 2x times x squared is 2x cubed, and we have a minus. And then 3 times the square root of x is 3 square root of x, negative 3x squared. Very straightforward. Multiplying this by x squared, we're going to get x squared over 2 square root of x. Multiplying this by 3x, we're going to get 3x over 2 square root of x. No big surprise. 2x times x squared is 2x cubed, and it'll be minus. And 2x times 3x is 6x squared. That will also be minus. So all these terms come out just fine. But remember, we have a minus here, so we got to put all this in parentheses, everything we got from multiplying these two binomials with a minus in front of it, so that when we distribute the minus through, all these last 4 terms are going to change sign. And I've also done a couple of things to the terms. Okay, so this term is going to become negative. Now, x squared over the square root of x, that's x squared over x to the 1/2. That's x to the 2 minus 1/2, which is x to the 3/2. X divided by the square root of x is x to the 1, divided by x to the 1/2. X to the 1 minus 1/2 is x to the 1/2. And then our 2x cubed and 6x squared. Now these two terms are going to be negative because of distributing the negative through. These two will become positive, again, from distributing the negative. And we've got all this mess, but this simplifies rather easily. We've got 2x to the 3/2 and a negative 1/2 x to the 3/2. Well, 2 minus 1/2 is 3/2, so we have 3/2 x to the 3/2. 2x cubed, negative 2x cubed, and a positive 2x cubed conveniently give us 0. We don't even have to write it down. It's a term. It doesn't have to be expressed. Excuse me. 3x to the 1/2 and negative 3/2 x to the 1/2. Well, 3 minus 3/2 turns out to be 3/2. So we have 3/2 x to the 1/2. And then we have a negative 3x squared and a plus 6x squared, which gives us a plus 3x squared. Our denominator hasn't changed. And I'm not sure I mentioned it. An x squared times the square root of x is an x squared times an x to the 1/2, which is an x to the 2 plus 1/2. 2 plus 1/2 is 5/2. That's where the 5/2 power comes from. Now, people I've seen are still having a little trouble with fractional exponents and radicals. So I'll just comment we need to get on that. Now, this does simplify a little more, so let's just go through a little bit of that. In the numerator, we can factor out an x to the 1/2, and I'll say it quickly, but I'm not going to go through all the details. And I think we're going to go ahead and just keep the coefficients. There are things we can do with the coefficients, but let's just concentrate on factoring out x to the 1/2. That's going to leave us what? Well, we're going to have 3/2, whatever's left out of x to the 3/2, and we divide it by x to the 1/2. Well, that's going to be x to the 3/2 minus 1/2, or just x to the 2/2, which is x. So we're going to have a 3/2 x. Just to check ourselves, x to the 1/2 times x is x to the 1 plus 1/2, which is x to the 3/2, and we still have the 3/2 out in front, so this works. Then factoring x to the 1/2 out here, well, that's really easy, so we're going to have then a plus 3/2, and factoring out an x minus 1/2 from x squared is going to leave us x to the 3/2, and I'll leave you to think about that, but we're going to have 3x to the 3/2. And of course, we can multiply back through here and check and make sure everything comes back to the original expression. In the denominator, we can factor out x because all these powers are greater than the first power. So we can say that's x multiplied by what? Okay, well, we got an x to the 4th. If we factor out an x, that's going to leave us an x cubed, because x times x cubed equals x to the 4th. And then we factor x out of x to the 5/2. That's going to give us minus 2x to the what? Well, we're going to have to reduce this power by 1 since we're factoring out x to the 1. That's going to give us the 3/2 power. And just to be sure, x to the 1 times x to the 3/2 is x to the 3/2 plus 1, which is x to the 5/2. So we're okay here. And then factoring x out of x, of course, leaves us 1, and that's easy to check. X times 1 is x. Okay? So now we have this. Now I'm going to do a last step. And in the last step, I'm going to rearrange these terms in an order of decreasing powers. So I'm going to have 3x to the 3/2 plus 3/2 x plus 3/2, all divided by x cubed. Well, it's going to be this, but let's see what else we get. Okay, well, x to the 1/2 divided by x is what? It's x to the 1/2 divided by x to the 1. That's x to the 1/2 minus 1, which is x to the minus 1/2. That is, we're going to have an x to the 1/2 in the denominator here. We could write that as square root of x, but since I'm using fractional exponents throughout, I'll keep this this as a fractional exponent, and then it's just times this, because this isn't affected when we divide these two terms. So we have x cubed minus 2x to the 3/2 plus 1. Chalk didn't cooperate with me very well. I'm writing that cubed, so I'm going to try to make it even worse. Okay, well, you can see. So that's a pretty acceptable final form. We could say, well, I don't want fractions as my coefficients, so we multiply the numerator and denominator both by 2. Then we'd have, what, 6x to the 3/2 plus 3x plus 3. And then we'd have a 2x to the 1/2 and times all this stuff in the denominator. And then, of course, we could factor out the 3. So maybe we factor out 3/2. Okay, so there's clearly more that can be done here, but wanted to talk mainly about what happens with the exponents. I'm not going to beat this horse any longer. I believe it's already pretty dead. So we'll leave it at this, but I'm going to actually put a equals, etc. here, because there is a little more you'd want to do. Now, I didn't want to inflict a verbal discussion of how we get from here to here on you, so I just put the equals, etc. But I will comment that I believe this is the correct form. And if you, well, I'll just leave it at that. And you can double check that for me. The thing you see from this is that the quotient rule can get kind of messy. Now, usually, I don't think we're going to see a whole lot in this course where the quotient rule gets any messier than that. I think this is about as messy as the algebra is going to get in a first semester applied calculus course. Second semester, when we get into a bit of multivariable calculus, there are opportunities for derivatives to get really, really bad. For example, calculating unit tangents and a little more than that, and you don't know what that means and you don't need to, because I don't think it's going to occur even in a second semester of this course. That occurs more in a full-blown multivariable calculus course. Okay, so this, just to tell you, this is about as bad as the algebra gets in this course. So this is manageable. It's kind of long, kind of tedious. You got to keep track of your factors, and you got to not make mistakes. And you've seen me make a couple of mistakes here, so you know that it's fairly easy to make them. But don't be intimidated by this. You can do this and understand that it doesn't really get a whole lot worse than this.